Okay, so a lot of people are tired of infrastructure and like all of the applications that doesn't work. And I really think that like the last decade was all about infras, and a lot of people are saying that the next decade would be about applications. And I think for seeing any kind of real adoption and real applications, we really need encryption. But there are some problems with the space. These are my favorite problems. There's a lot of misconceptions in the space. Like there's a lot of things that people randomly say which is not true. And there's like another kind of technical architectural problem, which is like inaccessibility and being pretty far for people to touch encryption or build with encryption. So I'll start with a couple of like very general misconceptions and talk about them, and then talk about the more technical stuff. So the first misconception that I've heard a lot is just when you talk about encryption or like privacy, most people think that it's like a same problem, but so like on one side, it's not just about anonymous transfers or like anonymous addresses or like shielded transfers. And on the other, so like we have other applications. We can use encryption for auctions, gaming, like mempool encryption, dark pools, or even like randomness generation. And there's a lot of things that you can do and build like unlock new applications that were even not possible on chain today. And on the other side, there's different layers of privacy. So we have like privacy when you want to use like MetaMask. People are like, I don't know, tracking your IPs, which is not great. So you can use like something like NEEM for like your privacy in the IP level, which is like somehow similar to Tor or VPN. We have privacy on the addresses, which is like all of the projects like, I don't know, Tornado Cache or like Penumbra, like Nameda, maybe like Anoma, like all kind of these projects using ZK are mostly about like anonymous transfers. And these are not really related to a like project like Zama or like us or like any kind of MPC team. And like a lot of people confuse that. Like they say that we understand, but like at the end of the day, they think they don't really get that, right? So I think it's just to make it like, make sure that everyone gets that. And I think what is like not solved, and a lot of people here in this room are solving, is like encryption of contents of a transaction. So we don't care about like hiding our activities or like our identities, but we care that we are not leaking important information on chain. So we care that when we are interacting with any kind of application on chain, we don't really want to leak what we are doing. Even if you are playing poker on chain, you shouldn't show your hand, right? So that's like an important problem. We have that in our real world. We have that when we are voting. We have that when we are, I don't know, like basically doing anything in our real world, and we don't have it on chain. And like most people here are building that kind of stuff. And the other thing, like, I'm sorry for like the mess up format, and I'm not sure why this is happening, but basically this is like my personal mental space about like privacy and encryption. Yeah, so like encryption and privacy are not the same thing. And all of the applications of privacy and encryption are not just DeFi. And like there's like other applications. And yeah. The other thing is like, yeah, just saying that encryption is ZK or ZK is encryption. So in almost most cases, ZK is not like cryptographically encryption. Like you cannot like hide some information in many applications. Sometimes you can do, but just like make it clear. And also encryption doesn't necessarily mean ZK. We have like, I don't know, thousands of cryptography schemes, and ZK is just like a certain category of that. And the other thing is like, although a lot of teams really want to say that we are building up one kind of a specific cryptography protocol that solves all of your problems, it's like 42, the answer to all of your, I don't know, problems in your life. That's not true, and it's not going to be true ever, because it's more of a like toolbox, and you have a lot of different tools in toolbox. They solve, like by default, they solve different kind of problems. Sometimes they solve the same problem, but like it can be an overkill. It can, like, I don't know, like there's like all kind of trade-offs in general, right? And sometimes you can combine them, like opening the new doors. So you can combine ZK with like TEs. You can combine ZK with MPCs. You can combine ZK with like FHEs. They are not like ZK versus TEs. It's not ZK versus MPCs. So it's not like a childish like fight with like cool school, I don't know, groups, right? And the other thing is like about NPCs in general. I'm sure that most of the crypto community, when you talk about NPC, they will think about like, I don't know, Fairblocks and like threshold signatures, threshold wallets, like this kind of stuff, which is like kind of true, but it's just like a very, very narrow application of NPCs and like cryptography applications. And so the other problem is talking about NPCs in the sense that it's like an actual specific cryptographic protocol. NPC is just like a very like vaguely defined problem in cryptography. And there's like thousands of NPC protocols and all kind of like iterations of NPC protocols or like different flavors. And this is not true. Like, so like when you talk about NPC on Twitter, make sure that you're talking about the same thing. Like I've seen a lot of like, like conversations on Twitter that they're fighting over something that they don't really know what they're talking about. And to me, like NPC is like the main branch. And the main branch that we have the flower in crypto is like signatures and wallets, but there's like those little cute birds that it includes like threshold FHE, it includes like IBC, it includes SPDC, and all of the applications that we can have encryption, right? So it's not signatures anymore. You can have some kind of computation over private information and then decrypt them, right? So in most cases, on the very high level, it's quite similar, but when you go, like, I don't know, devil is in the details. So the scalability of these systems are really, really different. And the security parameters are really different. And it's just not something that like, you can solve all of the problems with threshold FHE. You cannot solve all of the problems with like another PC scheme. And this is like my personal mental space. There's a lot of trade-offs between usability, which means that what you can actually solve with this kind of NPC schemes, and also the security of that scheme. So you can technically, all of the like NPC schemes, some of the good ones that are actually scalable to many parties, like n parties, not just like 2 parties, are based on like Shamir secret sharing or like DKG, which is like honest majority assumption. So in many, even like when you want to use like threshold FHE, in many applications, you still need like an NPC setup to decrypt the results, right? And the major criticism about that in the crypto community is that it's like based on the honest majority assumption. Technically, you can solve that. You can put that inside a TE and it will be solved, but it's like actual extra cost, right? So you don't really care about that kind of security if it's just like a voting mechanism for your game, right? So there's a price for that security that you should pay, and that's like the trade-off, right? And like if you use like threshold FHE, it's great, but it's like, I don't know, overkill for many kind of simple applications or computations. So that's like the performance side. And yeah, that's like, I don't want to go into details, but I just want to make you even more confused about all of these like ZK, I don't know, MPC or like FHE, and just show you that like, you know, just project the space of trade-offs and like what you can do with one of them and what's the price for that. So like, I think the more important one is like ZK, and the fact that with ZK you can do a lot of good stuff as long as the data is in your hands, right? So you can prove something about yourself with ZK ID. You can prove something about your own computation, but you cannot have private input composability. So that's like the major thing that something like FHE can be quite interesting, right? But like sometimes you just need like pre-execution privacy, and FHE is like an overkill for that. You don't need to pay the extra like price for like bandwidth overhead. And so like that was like the common misconceptions that I've seen in the space. This one is, I'm again sorry for like the messed up format. I'm not sure why this is happening, but the other problem is inaccessibility. And so talking about like Web 2, right? In Web 2, you are using like encryption pretty much everywhere in your messaging app, in like internet browsers, and nobody nags about that. Nobody like says that it's like bad. But nobody like actually, like very few people actually use Tor in their real lives. Although Tor is like a great technology, a great tool, nobody used that, right? The only people that I've actually seen using Tor is my like crypto friends inside our cryptography lab in university, or like, I don't know, or like very weird people. That's actually happening in crypto right now, because there is a lot of really interesting projects. We have like Alio, like ZK chains, a lot like, I don't know, 20 Cosmos chains that they have their own cryptography. But the problem is that it's really hard, like psychologically, technically, and financially, it's really hard for users to migrate their funds to that chain. And there is no builder, there is no actual application. You cannot ask like Uniswap to build their own DEX inside your chain, right? So for builders and users, it's like impossible for them to migrate to that chain, right? So this kind of accessibility for users, like not seeing that like already integrated seamlessly in the applications, I think that's the main problem. And I lost the. So that's like one of the things that I will talk about later. But before that, I just want to make sure that this is like the last misconception about like the legal problems. So there is a lot of fear, like any kind of new technology. So like I remember my grandmother was like, she was really afraid of like microwaves, and right now we are using microwaves everywhere, right? So a lot of people were like afraid of AI, and we are going to use AI more and more, right? This is like the same thing about like privacy or encryption. Of course, there is like very, very like edge corner cases that it can be potentially bad for some people with some beliefs. But I just want to make sure that everyone is on the same page that that's like only about mixers, which is not about cryptography. Mixing or like money laundering or tax evasion is bad, right, for a lot of people. But it's just like very specific cryptography scheme, which is ZK, and very specific use case of like DeFi, right? Even in these applications, there is other projects like Privacy Pool, which like Amin Soleimani and Vitalik is building, that are not like that bad, right? So just to be clear, building cryptography working on a hash algorithm is not like equal to going to jail. It's not fighting the US government. Like there is a lot of companies working on cryptography in the US. So you shouldn't be like afraid of working on cryptography libraries. Committing to GitHub library, it doesn't mean that you are in legal trouble, even building like something. And the funny thing is that in some cases, you can get yourself into trouble potentially for not having encryption, right? So like in a European country, like here, we have like GDPR. If you have like a centralized sequencer, maybe you get yourself in trouble if you're handling European citizens' data inside the US, if you are storing them, right? If it's just like an AWS server, like in the US, as a like centralized sequencer, it's probably better to encrypt them and isolate the legal risk and like manipulation like charges from yourself, right? So yeah, going back to the inaccessibility problem, I think one of the things that we've seen about ZK in general is that if you want to use any kind of ZK today, it's pretty out of reach. You either need like a giga machine, or you should be a giga brain to like install a Rust library, or like go, I don't know, submit something to RISC-0. Even RISC-0 is like very, very easy, but it's not like something that most people can do. Or like you should develop your own circuits, which is not true, right? So that has made the notion that cryptography means like horrible UX for applications, something that breaks the application. Nobody cares about that. If you talk about with any VC, they think that like encryption is cool, privacy is cool, but like that's like as comes with the extreme cost of UX and losing your users. That's not true, because like we have like 95% of our transactions are encrypted in Web 2. So that's not my grandmother. She's using advanced cryptography in Web 2. She's using like HTTPS, like TSL, but she doesn't know. So the beauty of that is that it's already integrated. It's seamless, right? So we can do that inside crypto too. Like we can integrate, like we can have lightweight libraries that can be integrated in the front end of the applications, in the wallets, and we can make it like, I don't know, very, very seamless. Like, unfortunately, not a lot of people care about UX, but at least it's not a fundamental problem that we cannot solve. Also about the delays. With ZK, they are still slow. Like there is like at least like a second of delay, or like submitting it to somewhere else. But with things like Zama or like an Artwork or like Suave or basically other kind of cryptography, it's not, the delay is not on the user side, right? It's like normal public key cryptography, like Web 2, it can be like as fast as 5 milliseconds. So in our case, I know that it's 5 milliseconds. You don't even notice that. So that's like the thing that I personally want to see in the space. So my vision is that like in Web 2, we have 95% of the transactions encrypted. In Web 3, we have even more reasons for having encryption on-chain. Because of the financial assets, there's a decentralization, and like even other applications like auctions or anything basically that you want to make build on-chain, you need some kind of at least like temporary privacy. And that's the properties that I want to see, like the programmability, not in the sense of ZK, in the sense of selective disclosure, and also in the sense of computation over encrypted data, so homomorphic encryption in a sense, and being available everywhere, which means for me seeing encryption in Arbitrum, in Optimism, in Ethereum mainnet, not in a random chain in the corner of the street. And simple for everyone, I already talked about that a lot, and fully compliant. So like, as I said, you can have a lot of different ways for being fully compliant. You can have pre-execution privacy, you can have DIDs, regulatory smart contracts, and in a lot of applications, actually nobody cares about the compliance. If it's like just a game or I don't know, auction, it's not something that you are in legal trouble for having sealed bid auctions. So that's like the term that I've invented, like modular encryption, and like starting from 2 examples, like we have Celestia, also like all kind of cross-chain bridges. Like all of these projects are Cosmos chains or like service provider chains. They are not their own ecosystem, but they are solving very, very real problems. So in the case of like Axelar or like Wormhole, they are solving a problem which is like cross-chain bridges, right? You couldn't do that natively in Ethereum because it's either very expensive or it's like technically impossible, right? So in the case of Celestia, they're offering the DA like in a like plugin way, okay. Pluggable way, and they're making like new kind of applications, make the UX better. So that's like my vision for encryption. So projects like us or like Fhenix, we are working on like co-processors, and basically the idea is that we can get the good parts in major blockchains, also abstracting away the bad parts, which is like cryptographic complexities, cryptographic computations in something like a co-processor or an AVS or something that just takes care of them like off-chain in a very like a scalable and cheap way. And this is like our architecture. And I just want to like most of our work is around like DeFi and MEV prevention, but it's not fun to see. So I just wanted to show like some of the applications that are like a little bit more fun. We integrated with like CoSwap recently, and the like fun thing is that you can encrypt your order while it's storing it will be on-chain, and we can encrypt it to different conditions, for example, prices, on-chain, execution triggers, or like even a ZK proof or like a price. And once that condition is happening, we can decrypt and execute that. So like your strategies, your contents of transactions will remain encrypted. You are not like leaking them before execution. The second idea is that we made a murder mystery game with like Celestia community. Basically, you can read the story, you can vote, and everything is on-chain. So like your vote is encrypted. While you're submitting your votes, your suspicion for like a murderer on-chain, other people cannot cheat by seeing your hand. And once the like block time is reached, you can see the murderer. Like the other thing is like private governance. So in general, like there's like anti-coercion problem with ZK-based just simply using ZK doesn't solve all of the problems with private voting. So you can use like things like MPC to solve that kind of problems. And we've built that for all of the Cosmos chains and like sovereign rollups. And like randomness generation, verifiable on-chain randomness generation is like a real problem. It's not that cool, but it's still a real problem. Yeah, that's all. Thank you so much, everyone.